Okay, so imagine this. It's a beautiful morning. You're in Cannes, France. You get your coffee, you sit down, you snap open the morning paper.
Just a normal morning.
The totally normal morning. You're just, checking the news, maybe the markets. And you flip to the obituaries.
Yeah.
And you freeze.
Because staring right back at you in black and white is your own name.
It's 1888. And the man reading that paper is Alfred Nobel. But the headline doesn't just say Alfred Nobel is dead. It says the merchant of death is dead.
I mean, that is just a brutal way to start your day. Not only finding out that the world thinks you're gone, but that they're actually happy about it.
Exactly. The paper had made this huge mistake. Alfred wasn't dead, his brother Ludwig was. But in the rush to get the story out, they got him mixed up. And so Alfred got to read a summary of his own life. They called him a wealthy butcher.
They said he got rich finding ways to kill more people faster than ever before. And that moment, I mean, that's really the hook for this whole deep dive, isn't it?
It has to be. Because when you hear the name Nobel today, you don't think butcher. You think Peace Prize. You think literature, physics, medicine. The absolute peak of human achievement.
So the mission today is to figure out how on earth we got from point A, this merchant of death, to point B, the ultimate patron of peace and science. Was this a genuine change of heart? Or was it maybe the most successful PR campaign in history?
To get that, we have to go way back. Before the will, before the prizes, we have to understand the chemistry of the beast he unleashed. We have to talk about nitroglycerin.
And we really need to get how terrifying this stuff was. Nobel didn't actually discover it. That was an Italian chemist, Ascanio Sobrero.
And he was terrified of it, right?
Absolutely petrified. He literally had scars on his face from an explosion in his lab. He stopped all his work on it and basically warned everyone, do not touch this stuff. It's too dangerous to ever be useful.
Okay, so let's break that down. At the time, the world ran on gunpowder. That was the standard. What made nitroglycerin so much scarier?
It's all about how they explode. Gunpowder is, well, it's clunky. Think of it like a cake mix where all the ingredients are separate. You have your fuel, the carbon, your oxygen source, and your accelerator, but they're all just separate little grains mixed together.
So the fire has to physically jump from one grain to the next to keep the reaction going.
Exactly. It's a physical thing. It's actually pretty slow, subsonic even. It pushes. But nitroglycerin? That's not a mixture. In nitroglycerin, the fuel, the oxygen, everything is in the same molecule.
So the cake is already baked, right down at the atomic level.
Precisely. And it is a very, very unhappy marriage of atoms. You have nitrogen bonded to oxygen. And oxygen is, it's an atomic bully. It's what we call electronegative. It pulls electrons away from the nitrogen, which makes that bond incredibly weak.
Like a rubber band stretched to its absolute limit.
That's a perfect analogy. And it doesn't take much to snap it. A bump, a drop, a little bit of heat, and snap.
And then what happens?
The atoms rearrange instantly into superstable gases like nitrogen and carbon dioxide, and that releases a massive amount of energy. And it happens in femtoseconds.
Femtoseconds. I saw that in the source. That's, what, trillions of times faster than a blink of an eye?
It's basically instantaneous. It creates a supersonic shock wave. It doesn't just push like gunpowder, it shatters. The blast pressure is like 100 times greater.
But the real problem wasn't just the power. It was the unpredictability. You could light it on fire, and it might just burn, but drop the bottle.
And boom! Yeah, it seemed to have a mind of its own. And that unpredictability, it stumped scientists for ages. It turns out it's not just chemistry, it's physics.
Physics.
Specifically the physics of bubbles.
Bubbles. Like
the air bubbles.
Exactly. Liquid nitroglycerin is kind of oily and viscous.
Yeah.
So it traps these tiny microscopic gas bubbles. Now, picture dropping a flask of it. As it hits the floor, the liquid compresses those tiny bubbles.
The basic physics is if you compress a gas that fast, it heats up. It heats up like crazy. We're talking about those bubbles becoming hot spots that flash to thousands of degrees.
So each little bubble becomes a tiny detonator inside the liquid.
That's it. That intense heat is what triggers the whole atomic chain reaction.
You know, the source used this great analogy with a beer bottle. That party trick where you hit the top of the bottle really hard and the bottom just shatters.
Right. Cavitation. It's the exact same principle. You hit the top, the bottle shoots down, but the liquid inside lags for a split second. That creates a vacuum of bubble at the bottom.
Then the liquid slams back down, the bubble collapses, and that collapse is so violent it cracks the glass.
And that's what's happening inside the nitroglycerin. Just handling it roughly creates these tiny cavitation bubbles. They collapse and the whole thing just goes off. It's a liquid landmine.
So enter Alfred Nobel. Why on earth was he so obsessed with taming this stuff?
Well, it was kind of a family thing. His father, Emmanuel, was an inventor who went bankrupt trying to make sea mines for the Russians in the Crimean War. He was a brilliant guy, but just a terrible businessman.
So Alfred grew up with that failure looming over him.
He did. He saw his family lose everything, his brothers selling matches on the street. He was driven to succeed where his father had failed. He saw the potential. The world needed to blow up mountains for railways. Gunpowder wasn't good enough. If he could make nitro safe, he'd be the richest man on Earth.
And his first big breakthrough wasn't stabilizing the liquid, was it? It was figuring out how to set it off reliably.
The blasting cap. And honestly, this invention is arguably just as important as dynamite itself. Nobel realized that since a simple flame wasn't reliable, you needed a small primary explosion to trigger the big secondary one.
Like a pilot light, but, a very violent one.
A very violent one. He used a little metal cap filled with something sensitive, like gunpowder or later mercury fulminate. You light the fuse, the cap pops, and that sends a tiny supersonic shockwave into the nitroglycerin.
And that's what snaps the molecular bonds. Not heat, but shock.
Exactly. He engineered a way to bypass the whole bubble problem and just use pure force. And that basic principle is still used in everything today, from construction demolition all the way up to nuclear bombs.
But getting there, the road to that invention was just paved with horror.
We can't gloss over that. In 1864, the Nobel family factory in Stockholm it exploded. It was a catastrophe. The descriptions from the source material are just gruesome, talking about formless masses of flesh.
And one of those victims. It was Alfred's younger brother, Emil. He was only 21.
Yeah. And Alfred was there. He survived, but his brother didn't. The city of Stockholm was done. They banned all nitroglycerin production within city limits. Alfred was basically an outcast.
This is the part that's just wild to me.
Yeah.
Most people would quit, right? Your brother is dead. The city has banned you. But Alfred just moves his lab onto a barge on a lake. He's literally an exiled scientist floating around mixing explosives.
It just shows you how driven he was. He called himself a nomadic atom. He knew he was close, he had the detonator, but he still needed to solve the transportation problem. He had to turn the liquid into a solid.
So he starts mixing it with everything: charcoal, sawdust, brick dust.
He's desperate. He just needs some kind of sponge, and then he finds it, pretty much by accident, in the ground near his new lab in Germany, Kieselguhr.
Kieselguhr. Sounds super scientific, but it's basically fossilized pond scum, right?
Pretty much. Diatomaceous earth. It's the fossilized skeletons of these ancient single-celled algae called diatoms, and under a microscope, they're these incredible, tiny, hollow structures.
So, a microscopic sponge.
The perfect microscopic sponge. He mixed the liquid nitro into this chalky powder, and the diatom skeletons just soaked it right up. But the key was they separated the nitroglycerin molecules inside their tiny pores.
So the droplets aren't all touching each other anymore. You can't set off a chain reaction from a simple bump.
Right. It cushions them. You could drop this new paste. You could hit it with a hammer. It wouldn't explode. It made the explosive insensitive.
But if you stick a blasting cap in it.
The shock wave from the cap is powerful enough to set it off. He had done it. He called it dynamite, from the Greek word dynamis, for power.
Okay, I have to ask. Because of, cartoons, the red sticks always say TNT. Is dynamite the same as TNT?
I am so glad you asked this. It is a huge pet peeve for chemists.
Yeah.
No. Absolutely not. Dynamite is not TNT.
Thank you. My whole childhood was a lie.
TNT is trinitrotoluene. It's a totally different chemical invented decades later. It's much more stable. Dynamite is nitroglycerin absorbed into a stabilizer. TNT is its own solid chemical compound. So while E. Coyote was using the wrong label.
Okay, my world is right again. So Nobel has dynamite. He has the blasting cap. Suddenly, he's the king of the industrial age.
Oh, absolutely. He's blasting tunnels through the Alps for trains, clearing harbors, building canals. This was the era of mega projects, and dynamite made them possible. He was becoming fantastically wealthy.
But, and it's a big but, he didn't stop there. This is where we start sliding towards that Merchant of Death title.
It's the classic slippery slope. He just kept innovating. Dynamite had a problem. If it got wet, the nitro could sweat out of the Kieselguhr and become dangerous again. So he invented gelignite.
That's the one from the story where he cut his finger.
Yep. He cut his finger, put on some collodion, which is basically a liquid bandage made of nitrocellulose, and had a revelation. He mixed nitrocellulose with nitroglycerin, and it created this waterproof, explosive jelly that was even more powerful than dynamite.
And then came the straight-up military stuff.
Ballistite. This changed warfare forever. Up until then, battlefields were just choked with smoke from gunpowder. The fog of war was literal. You couldn't see anything.
Which is a huge tactical problem.
Massive. Alfred created a smokeless powder. It burned slower, more evenly, which meant bullets flew faster and farther, and critically, it left no smoke trail.
So suddenly you have modern snipers. You can shoot without giving away your position.
Exactly. It revolutionized combat. He sold massive quantities to the Italian government, and that's when the Merchant of Death label really started to stick. He wasn't just moving mountains anymore. He was making killing more efficient.
Which brings us to the morality of it all, because he wasn't just some cackling villain. He had this strange justification for it all, didn't he?
He had a very, let's call it a unique theory on peace. He was friends with a peace activist, Bertha Kinsky, who was always telling him to stop making weapons.
And his response was basically, my way is better.
He flat out told her, my factories will put an end to war sooner than your Congresses. It was this idea of mutual annihilation. He truly believed if weapons got so terrible that two armies could wipe each other out in an instant, no one would be foolish enough to start a war.
That sounds disturbingly familiar. It's the Oppenheimer argument, the nuclear deterrent.
It is the exact same logic, and it was a massive, massive misjudgment of human nature. He thought horror would breed peace, but horror just bred more efficient horror.
And it wasn't just armies using his inventions. This is where it gets really dark. Dynamite. It changed the game for individuals, too.
It was the democratization of destruction. Before dynamite, if you wanted to cause mayhem, you needed a cannon. It was hard. Dynamite was portable. One person could carry enough in a briefcase to bring down a building.
Enter the anarchists, the Dynamite Club.
Yes. The late 19th century was rife with bombings. Wall Street, London, Paris. It was really the birth of modern terrorism as we know it.
The source brought up the Bath School disaster in 1927, which is just a terrifying example of this.
It's still the deadliest school massacre in American history, and it wasn't done with guns. A man wired the school with hundreds of pounds of dynamite. It's a chilling reminder that Nobel's invention didn't just help build railroads, it gave horrifying power to anyone with a grudge.
So let's circle back. It's 1888. Alfred's reading his own obituary. He sees himself called the butcher. He sees the wars, the terrorism, and he's utterly alone.
That's the key. He was one of the richest men in the world, but he had no wife, no kids. He was sickly, depressed. He realized that if he died right then, that was it. His legacy was death and destruction. Full stop.
And he couldn't live with that. Or die with that, I guess.
He decided to rewrite the end of his own story. He sat down and wrote a new will, a short, simple document that left 94% of his massive fortune to fund a series of prizes.
Physics, chemistry, medicine, literature, and peace.
The irony is just staggering, isn't it? The Nobel Peace Prize is funded directly by the profits from ballistite and dynamite. The money comes from weapons factories.
That is the paradox at the heart of this whole story.
Yeah.
So let's land the plane here with a big question. Did it work? Did he fool the world? The source video showed those interviews where nobody even mentioned dynamite.
He didn't. They all said Peace Prize, awards, geniuses. So if his goal was a rebrand, it was an unqualified, massive success. He completely buried the Merchant of Death.
But does it erase where the money came from?
And that's the question for you listening. Is it blood money? A guilt payment from a lonely old man trying to buy a clean reputation? Or is it redemption? Taking the profits of destruction and dedicating them, in perpetuity, to the best of what humanity can be.
It really makes you ask, is a person's legacy defined by how they make their money or by how they spend it?
And maybe it proves that it's never too late to change your own story. Even if the world calls you the Merchant of Death, you get to write the final chapter.
A good thought to leave you on. Next time you see a Nobel Prize headline, just remember the bubbles, the blasting caps, and the bad obituary that made it all happen.
Thanks for diving deep with us.
We'll catch you on the next one.